There we go. Okay, we're going to graph y equals 1 over x. And I'll take this line out of here. It kind of confuses things. But there it is, 1 over x. And we all know y equals x is a line, one of the easiest functions to graph. So you would think that maybe y equals 1 over x wouldn't be too bad. But it actually is quite a complicated function. And normally I just do a few points. But notice all the points of it I'm going to determine on a t-table here. Got all these x's we're going to find the y's, and then we're going to plot them. And then I've got more points on the next blackboard, and this gets to be quite complicated, and that's why I have so many points. Let's take a look at this. One nice thing about 1 over x is 1 over x, I'm going to put 1 in for x, I put 1. It's clear that I have a 1 there. And when I put in 2 and 1 over x, I get 1/2. And when I put 3, I get 1/3. It's pretty easy to evaluate. That's one thing. And when I put 4 into 1 over x, I get 1/4. And of course, if I put -1 into 1 over x, 1 over -1, I get -1. If I put -2, I get -1/2, -1/3, -1/4. So it's very easy to plug x values in here if they're just integers and evaluate this thing. Now when I go to plot this, I'll go 1 and 1 here. There's my first point. And then I'll get 2 and 1/2, 3 and 1/3, 4 and 1/4. And if I went to 5, it would be 5 and 1/5, 6 and 1. It would get very, very close to the x-axis. So when I get out to 1,000,000, it would be 1 over 1,000,000. But it would never touch the x-axis. Never touch the x-axis. Just get closer and closer and closer to the x-axis like that. We have a name for this. It's called asymptotic behavior. Our graph is asymptotic to the x-axis or the line y equals 0. Now if I go to the other side, I look at put -1 in, I get -1. -2, excuse me, I get -1/2. -3, I get -1/3. It does the same thing, only from the bottom. So it looks like this. And if I get out to -100, it's going to be -1 over 100. It's negative, but it's getting closer and closer to the x-axis without touching it, but from the other side. Now,
I have a question.
Yes.
You said that our function becomes asymptotic to the x-axis.
Right.
And in this example, y equal 1 over x, it never crosses the x-axis.
That's correct.
Is it possible for a function to cross its horizontal asymptote?
Yeah, it's possible. Yeah, there are functions that can cross the, say, an x-axis or any horizontal line and eventually be asymptotic to that line. That's possible. With this function, though, it's much simpler. You have to have a little more complicated function. Now, actually, before I should have done this, I should have looked at the domain, but I think it's pretty clear here that x can't equal 0. So we're talking about a domain that goes from -infinity all the way to 0, not including 0, or 0 all the way to +infinity. And we've only looked at values greater than 1. We started putting values like 1, 2, 3, and out to as far as we want to go, and then -1 all the way out. Now I want to examine -1 to 1. This area here, not including 0, but there is each one of these points in between -1 and 1. We can plug into this function as long as we leave out 0. And we're going to go over here and look at that, this interval here from -1 to 0. Okay? And that has peculiar behavior. That has some peculiar behavior. If I put 1/2 into, in other words, here's 1 over x, I'm going to put 1/2 in there. Of course, you know about fractions. You flip it over and you get 2. If I put 1/3 in there, I get 3. And when I put 1/4 where x was, 1 over x, 1 over 1/4, I get 4. And if I put 1/5 in there, I would get, in other words, as I put in values that are closer and closer to 0 from the right here, I get bigger and bigger values. The same thing happens when I put in -1/2, I get -2. If I put 1 over 1, -1/3, I get -3. And if I put 1 over -1/4, I get -4. So I get these values. Now let's take a look and see what this means here. If I put in 1/2, I'm going to get 2. If I put in 1/3, that's about 1/3 right there, I get 3. When I put in 1/4, x equals 1/4, I get 4. And that's a little better than that. So what happens is if I put in 1 over 100, get very close to 0, I get 100. If I put in 1/1,000th, that's almost touching 0, but not quite, 1 over 1,000,000, right? It's getting closer and closer. Then I have 1,000,000. So this thing is growing without bound. I mean, it just grows and grows and grows as we put in values closer and closer to 0. And remember, there's an infinite number of values between 0 and 1. So as we get, and actually any interval, there's an infinite number of values in any interval. So we have an infinite number of these values get closer and closer to 0, and this goes as high as you'd like it to go. The same thing happens at the other side. If I put in -1/2, I get -2. If I put in -1/3, I get -3. And this grows without bound this way. And we say this function is asymptotic to the y-axis, or the line x equals 0, because it gets closer and closer and closer, but it never touches it on this side and on this side. And we get this graph. Now, for you, we've plotted this thing. We're done. You don't have to do this every time. And if somebody asks you, please plot the graph y equals 1 over x, here's what you'll do. You say, okay, here it is. In other words, you don't plot points. You just know how it goes.